Alright, this is going to be our example 4. We can tell there's a lot going on with this graph. If I move this point around, you can see there's different components, different pieces, because it is a piecewise graph. Let's go ahead and get started with asking some questions about this graph. For the first example of sub-example of example 4, evaluate the limit as x approaches -4 from the left of f of x. So we're going to go to the left of -4. We're going to see what happens to the y value. Again, that's the limit. It's what the y value is approaching as x approaches, in this case, -4. And again, we can see that the y value is going to go up forever, right? So therefore, the limit as x approaches -4 from the left is going to be infinity, because y is going to just keep going up, up, up. So there you have it, infinity. All right, let's look at the next part. Let's find the limit as x approaches -4 from the right. All right, so we have to kind of go, we have to go down to this little piece right here, because we're approaching -4 from the right. And actually, here's what's crazy. It actually gets there, doesn't it? It actually reaches -1. Now, that's going to be the limit. However, it didn't have to reach -1. All I had to do was approach it. All right, so therefore the answer is going to be -1. So as you can see, we're mixing finite and infinite limits. Okay, -1 is a finite number. Infinity and negative infinity are obviously not finite. Okay, next up, let's do the limit as x approaches -3 from the left. So here's -3. Sorry, let's see if I can just circle. Okay, there's -3 right there. It's this hole right here. So if we approach it from the left, then the y value is approaching what? Well, it's getting closer and closer to the x-axis, right? Which is y equals 0, right? So therefore the limit as x approaches -3 from the left, whoops, I didn't mean to jump, is going to be 0. I like to break things down the best way I know how. All right, let's approach -3 from the right and see what the limit for that would be. So if we approach -3 from the right, we have to put the point down here on this piece and see again. You can see x is approaching. Well, it actually reaches -3. You can see x approaches -3, and in this case, since it gets there, we'll just go ahead and illustrate the fact that yes, the limit's going to be -2. So let's go ahead and reveal that. A few more components to this graph. Let's do the limit as x approaches -2 from the left of f of x. Here's -2, so we're just going to stay on the same piece and drag x closer to -2, and we can see the y value is going to go down forever, meaning it's going to be approaching -infinity. Again, if you have any questions about this, just feel free to ask. That's how you learn math or any subject. You ask questions. Let's make sure x approaches -2 from the right and see what the limit is there. Well, if -2 is approaching from the right, it's going to have to be up on this piece. As we can see, x is going to be approaching -2, and the y value is going to do what? It's going to approach infinity. It's going to shoot up like a rocket. That's one way to think of it. If the y value shoots up like a rocket as x approaches a number, in this case -2, then the limit must be infinity. I think I just copied and pasted this for some reason, so you could kind of see them both on the same page. Anyway, as you can see, the y value is just going to keep going up and up and up. Maybe I should draw like an arrow right there or something to illustrate what's happening to the y value. Okay, example 4.7. Evaluate the limit as x approaches 0 from the left. All right, so let's drag this bad boy down. And here's x equals 0, right? This line right here. So we're going to approach x equals 0, and it's not going to get there, right? Because there's a hole. But what's happening to the y value? It's approaching 2, right? And you can't see that on the axis labeled, and I apologize for that. It's just the way this program works. But you can see it's right below 3, so it must be 2. All right, so the answer is +2. We have one more. Evaluate the limit as x approaches 0 from the right of f of x. Okay, so we're going to go on this piece, and we're approaching from the right, so it's moving left. And this time it actually gets there as x approaches 0, y approaches and reaches 1. Again, it doesn't have to reach it, but in this case it does. Therefore, because it was approaching 1, the answer is 1 for our limit. Okay, folks, that's it for this graphic example of infinite one-sided limits. This one mixed it with finite limits as well. If you have any other questions about it, let me know.